Well, thank you so much. I'm happy to be here, and well, I would like to speak Japanese, but unfortunately I don't. So, I hope you can follow the test, and of course, if there is some problem in understanding, stop me, and I'll try to explain. Actually, I'm going to start with something that it's not in the text, and it's in a sense the kind of inspiration of this talk, because the idea came when I hope that here it's okay. Yes, when I read this in the Okakura Katsuko, the Book of Tea, this quotation struck me because he said, you see, the philosophy of tea is moral geometry in as much as it defines our sense of proportion to the universe. And I found this proposition, I mean, this statement, very, how can I say, in contrast with the usual way in which I and philosophy of science and in the Western culture see geometry. Actually, what is peculiar here is that Okakura is talking about moral geometry, and instead people like Leibniz or Spinoza talk about the rather geometrical moral. So they see that moral has to be geometrical because there has to be a rule, there is to be a mathematical rule in the moral. Instead, Okakura talk about moral geometry. So it's just the opposite. And so I wanted to explore a little bit why we are so obsessed, in a sense, with geometry and with mathematics, and so this is the reason why I was trying to see this through images, through painting, and above all in the way in which geometry is used in order to make precise the rules of the propagation of light, and so the way in which geometry is connected with the science of light, and of course with the transformation in the culture. Light, of course, is not only connected with art, but it's even, and it's also connected with moral, and this is again what we are going to explore. The starting point of my talk, well, here I outline let's say the chapter that I'm going to explore. I would like to start with the character. I'm going to see why there is this kind of connotation in our thought, that is why the mathematics and geometry is so important, so the characters of Western philosophy. And then how the science of light became important in the medieval age in order to explain in order to explain the puzzle that was posed by the infinite of God. And the science of light, of course, was the optics. And so the way in which a physician and mathematician was studying the laws of propagation of ray in order to understand the science of light. Then geometry of the ray, that means when mathematician, in a sense, well, artist more than mathematician, we should say, changed the rule of perspective, because in the medieval, optics is natural perspective, so it's the study of the propagation of natural light. And then the artificial perspective, linear perspective, is what the artists did in the Renaissance. That means they changed the law of propagation of light in order to adapt them for the artistic representation. And what's the meaning of this operation? So the geometry of vision and the substance of colors is what happened in the Renaissance, when the geometry of vision changed according to the rules of artificial perspective, and at that point color and lines also were the means by which the artist tried to represent the reality. And then at a certain point, the reflection about the way in which artificial perspective changed the rule of geometry posed the question of what was the right geometry. So it was the geometry of Euclidean geometry, that means the rules of propagation of light according to the natural geometry of Euclid, or the geometry that came out from the painting of the Renaissance, because the two geometries are different. And at that point, there was a turning point in the reflection of Leibniz that somehow invite to reverse that perspective and to consider that the light comes from the eye of the observer, and so it changed the rule of light and shadow in the construction. And at that point, shadows also become important, and it's the interaction between light and shadows that somehow was the way in which the reflection after the Renaissance go ahead. Anyway, let's start then with these lines from the Paradiso of Dante Alighieri. I read it in Italian because, well, qual è geometra che tutto s'affigge per misurarlo cerchio e non ritrova pensando quel principio dell'indige? Tale era io a quella vista nova. Veder voleva come si convenne l'immago al cerchio e come vi s'indova, ma non eran da ciò le proprie penne. You have also the English translation, well, here, but also in the text. In this line, Dante describes the impossibility of understanding how the face of Christ, the embodied God, which is seen in the second circle of the Trinity, the Son, can be related to the first circle surrounding it, that means the Father. His condition is like that of a geometrician who wishes to measure the area of a circle but did not know the principle. The principle is pi, the number that gives the relation between the circle and the ray. That would allow him to find the ratio between the square and the circle. The principle he wants, il principio dell'indige, lies in the mystery of that number, an irrational number, because of its infinity. Because the infinity of many decimal is incomprehensible to human mind. Nevertheless, it allows the finite human horizon to glance at the spark of the infinite, a flash of lightning, said Dante, wherein came the wish. Se non che, and then you go ahead, se non che la mia mente fu percossa da un fulgore che in sua voglia svenne, all'alta fantasia cui manco possa. Both the wings of imagination and l'alta fantasia, that the lofty fantasy, which allowed a geometrician and the poet to guess an invisible content, the mystery of the Trinity, are now inadequate. The geometrician, the geometer, and also the poet has to surrender facing the enigma that goes beyond natural and human reason. This enigma of the relation between the square, the polygon that represent the face of Christ, and the circle that in the representation of Dante represent the Father. But why this? Why Dante is using this image in the Divina Commedia? This is strange. The fact that he asked the geometry to give an explanation of the fact that he cannot understand the mystery of Trinity. So this speculative attitude, which seems distinctive of the Western culture, has its roots in the Greek thought. As Plato explained in the Timaeus, When the world began to get into order, fire and water and earth and air had only certain faint traces of themselves, and were altogether such as everything might be expected to be in the absence of God. There was chaos before the God intervened in putting order in the world. This was their nature at the time, and God fashioned them by form and number. So God, actually the demiurge in the cosmos of Plato, intervened in order to give form to the universe, and the form that they take are the form of this natural solid, and are the form you have seen that correspond to the fourth element. Sorry. Okay, this is the form of the water, and then there is a fifth solid that later on would be associated with the ether, but not at the time of the Timeo. Goodness and beauty emerge from the order of geometrical forms and numbers. Reason and proportion allow the demiurge to extend such an order from the ideal to the sensible worlds. Plato's cosmos, with its separation between the perfect, immutable world of idea and the changeable, sensible world, captured the clearest image of the Greek mathematical philosophy. The development of the Western philosophical thought can be viewed as a change of more and more sophisticated attempt to make productive that dialectic contrast. It's a great achievement of the Greeks, writes Hermann Weiss, to have made the contrast between the finite and the infinite fruitful for cognition of reality. Regarding the infinite, however, the ancient Greeks saw it as potential, namely as a possibly endless continuation of a process. The possibility of a complete, closed infinite, the actual infinite, was not at issue. Such an infinite goes beyond the ratio of natural number. And it was the rationale behind the Christian religion that created the demand for a comprehension of the infinity. Notice that in the Judaico-Christian cosmos, the demiurge, namely an artisan able to conform so much as possible the sensible world to the eternal world of ideas, leaves the floor to an infinite and unique God, an eternal being able to create all things, ideal and real, out of nothing. Also, okay, this is the image that Raffaello gave in the creator in at the Museo Vaticani. So 4th century and in the medieval Europe, the conflict between truth and faith and truth and reason urged the Christian philosophy to ask geometric optic for enlightenment. If faith cannot be divorced from observation, and revelation need to entrust a common language, and this common language comes from mathematics. Well, here are paintings that we have already seen that represent the way in which the struggle between the finite and the infinite, and also in the representation where we have the illumination that comes from the book of the geometry and the illumination that comes from the faith. Light was taken as the analogous of the divine grace, but light was primarily a natural phenomenon, following the rules of the ray propagation. As long as the form of nature shows the divine design, Euclidean geometry could help refine both the observation of nature and the comprehension of God. And here is the beginning of the science of light. This is the reason why the science of light, the study of light, became important. 4 centuries before Galileo, Robert Grosseteste, Franciscan philosopher and Bishop of Lincoln, claimed that without considering lines, angulis, and figures, actually, the natural philosophy would be incomprehensible. Gross test also specified physicists know what, il quid, whereas experts of optics, I perspettivi, know why, what is called the propter quid. The quid is the substantial cause, whereas the propter quid is the cause derived from the definition of the thing, since the definition is the beginning and the end of the proof. Light is the first beginning, the form or quid, or essence, common to all natural beings, and allow the construction of a demonstrative science. By connecting the Platonic doctrine of light to the Aristotelian conception of a demonstrative science, Grosseteste sought a causal explanation of the generation of forms through the analysis of the behavior of creatures according to the different modes in which light acts. The idea of an active, luminous matter capable of generating forms was further developed in the Multiplicazione Speciarum by Roger Bacon. Species is the effect of natural agency and presupposes both an action and a substratum of matter inclined to receive it and to be modified by it. The laws of the multiplication of species follows the route of natural perspective, namely of optics. The demonstrative science of the medieval perspectivi has an Aristotelian character and pushes substantial causes rather than functional links. Nevertheless, the conception of a science of light as a demonstrative science hands over a mathematical language to visual phenomena. From the science of light, here there is an error, it's not the science of art, from the science of light, the idea of a mathematical design of nature took hold of the Renaissance scientist. Approaching the study of nature as a mathematician, the scientists seem a theologian with nature instead of God as his subject. Mathematical truth could not be obscured, and its light followed from the divine to the human intellect. And here we have a quotation from Galileo that he said, "It's true that the divine intellect cognises the mathematical truth in infinitely greater plenitude that does our own. But it knows them all, but it's just a problem of number in Galileo's opinion. But the few that the human intellect may grasp, I believe that cognition equals that of the divine intellect as regards cognitive certainty, since man attained the insight into their necessity, beyond which there can be no higher degree of certainty." So for the few things that human reach, there is the same degree of certitude that there is for God. So God knows much more, but it's an issue of numbers. The geometry of vision, then, what I want to stress is that the study of light was in order to understand the way in which light allow us to have a right representation out of a right observation of nature. And this is the reason why the science of light passed from the perspectivi to the scientist. And this was the study of light regulated by the Euclidean geometry. But the problem of vision required an adequate reading of the way in which the light radiating to the space affects the spatial relation and the geometry of body. But the problem of the objectivization of vision would require a new perspectival space. According to Panofsky, the antique conception of an inhomogeneous space of aggregates is abandoned when the Romanesque fully mature, fully mature by the middle of the 12th century, shed all vestige of antiquities and renounced all spatial illusionism. For if Romanesque painting reduced body and space to surface in the same way, with the same decisiveness, by this very means, it also managed for the first time to confirm and establish the homogeneity of body and space. It did this by transforming their lost optical unity into a solid and substantial unity. The way in which the Romanesque resolves the antithesis between bodies and empty space in a new plastic composition ought to be regarded as a concrete application of the theoretical principle of medieval perspective derived from the Arabic philosopher Al-Kindi. Although both Grosseteste and Bacon placed the spiritual enlightenment coming from faith about the human and the philosophical experience of vision, their ideal of a contemplative science in the Greek tradition is dialectically related to an active conception of nature derived from the Radis, the theory of race, by Al-Kindi. For Al-Kindis, things act and leave signs of impression of their action in different ways according to certain rules. All action occur in line with the laws of radial propagation, namely with geometric optics. But the Euclidean geometry cannot correctly explain what rays are, because rays are not purely abstract mathematical entity. They must have the power of operating. Then geometry must be materialized. If rays has not concrete extension as Euclidean lines, they would have not physical effect, and therefore they would be not perceivable. But vision is a sensory phenomenon, and the certainty of the truth in demonstrative and geometrical science ought to rest on sensory evidence. So light is not an abstraction, but a material quid, which generates sensible and intellectual experience through its action. Matter is the first essence and anticipates form. Specification, or in general differentiation, is bound to the capacity of recognized forms. It's this capability that allows identifying objects through sight and therefore knowing. Thus, in the action of light as a material quid, that makes possible our knowledge, and any demonstrative statement is based on the capability of recognized forms and applying the rule of light propagation. Carrying over concept and method of the medieval perspective into a plane surface, the Renaissance artists invented the artificial perspective. The result is a painting or draw image which appear to be indistinguishable from the image transmitted by a glass or reflected by a mirror. It's achieved by projecting the three-dimensional scene onto a plane, letting the flight lines converge to a central point, mirroring the unmoving eyes of the viewer. In perspective drawing, Al-Kindi's rays are freed from their material character. Again, the light reconquer somehow the freedom to go without the weight of matter. The beams of light can follow paths not determined by natural law. Traveling in parallel, they could meet in one point and therefore give shape to an ideal representation space. The invention of perspective is attributed to Filippo Brunelleschi. It provides an effective procedure, a technique for transferring the real vision into an artificial space. As we read in the Piero della Francesca Perspettiva Pingenti, he gives the rule for this perspective. He said, first is sight, that is to say the eye. Second is the form of the thing seen. Third is the distance from the eye to the thing seen. Fourth are the lines which leave the boundaries of the object and come to the eye. Fifth is the intersection which comes from between the eye and the thing seen, and on which is intended to record the object. Perspective is not solely a technique of representation. for Leon Battista Alberti, Piero della Francesca, Leonardo, and even more for Dürer, it's both an optical art and a science of painting. It makes painting a science drawn from Euclidean geometry, but it makes optics and art capable of creating a symbolic and imaginary space. It's not an art intended as a pure fiction, independent of the rationale of nature. It's not a science intended as an accurate description of natural necessity. It's, however, costruzione legittima, for it ties the artistic representation with the scientific vision of its author. An art of drawing which binds its freedom of representation to mathematical rules, a science of seeing which asks the artist's eye for the principle of the description. At the boundary between art and science, perspective finds its meaning in making one commensurable to the other. But besides mastering the rules of linear perspective, painters are also required to find appropriate means to substantiate their perspectival view, to create a synthetic system to be fitted in the abstract space. Well, sorry. While the geometry of vision projected reality onto the figurative plane, light and colors allowed a new perspectiva pingendi to grow out of that plane. Perspective synthesis of light and color, of form and color, is the expression that Roberto Longhi, is in Italian criticism of art, to illustrate the distinctive fabric of the Venetian painting as well as of Piero della Francesca. Here we have an example of the Piero della Francesca. In mathematical terms, one could say a coherent system where the geometry of light merges with the algebra of colors. Actually, an analogous synthesis might be recognized in Descartes' system of algebraic geometry. Descartes attached numbers instead of color to geometrical points. Since numbers also measure physical quantities, the values of these quantities fill the point of the space. Then matter can penetrate into the space and become res extensa. Art and science of the Renaissance seek the harmony of the nature in the static form. Actually, for seeing the static form and the character of the Renaissance painting of the Quattrocento, I would say, because then this, I think, is an emblematic example of painting. Even the representation, of course, because here we have again the mystery of the figure of Christ. And actually, Piero della Francesca, that is a painter, but of course is also a great mathematician, just in this painting used the ratio between the two sides of this rectangle are exactly the ratio between the diagonal and the light of the square. And this is, because this incommensurable issue was very urgent for the mathematician of the Renaissance, and Piero della Francesca, and of course this problem was connected also with the representation, and in this painting, the flagellation, Piero, represent, of course, the relations between the finite world of man, of political man, and the mystery of the incarnation of Christ, but also the way in which he used the geometry is in order to give the message that the incommensurability that is there. So art and science of the Renaissance seek the harmony of nature in static form, I would say. I was about to say, not in the dynamic laws. Alexandre Koyré observed that if the Renaissance scientists replace a world of qualities with a world of quantities, and the world of the becoming with the world of the being, this is because numbers and figures are motionless. He also emphasized that while Descartes fails in his attempt to reconstruct the world on the identity of matter and space, Newton succeeded in constructing a modern physical world by recreating distance between the corpuscular matter and the empty space, and above all, by transforming mathematics in the guise of physics. In contrast with both Descartes and Newton, Leibniz's work grows out of a vision of geometry in which the law of continuity replaced the Cartesian res extensa, and a theory of nature in which organisms replaced the material points of the Euclidean physics. What is particularly interesting in the present context is that Leibniz's view emerged from what is called a doctrine of shadows. The doctrine of shadows, as Leibniz says, is nothing but a reverse perspective. It's drawn from perspective once the light replaces the eye, the opaque replaces the object, and the shadows replaces the projection. While the Renaissance painters, think in particular of painters like Piero della Francesca or Albrecht Dürer, regard perspective as an art of measure drawn from Euclidean geometry, Leibniz asked perspective to guide the construction of geometry itself. Pondering over the construction of geometry, he realized that something is missing. Imagine, he wrote, taking 2 points in space, hence conceiving the indeterminate straight line through them. One thing is that each point is regarded individually as single. Another thing is that both are regarded as simultaneously existing. Beside the 2 points, something else is needed for seeing them as coexistent in their respective positions. When we consider one of these 2 points as if we took its position and look at the other point, what the mind determines is called direction. So 2 points don't determine a line, because in order to draw a line, something else is needed. This something else is or the principle of continuity or the intuition of the motion that goes from one point to the other. So what Leibniz is stressing is that the elements of geometry actually are not sufficient to construct geometry. There is something missing. And what is missing is the principle of continuity. Yes, what is missing in the elements of geometry is the principle of continuity. How Leibniz put it, continuum is also where parts are indefinite or solely mentally designed. So between the 2 points, there is something that even the void, even the space between the 2 points has to be considered. Hence, a line is the extension described by a point's motion. In the light of continuity, what does not change through the ideal motion of a point between 2 sides, it's what is shared or what is shared by 2 points ideally separated is the direction. Focusing on the situs that a point can take, on the place that can be occupied by a point, Leibniz regards the Euclidean points as viewpoints, and therefore replace the Cartesian res extensa, the extending thing, with a subject extended oneself. Yes, he said, as the extension is just something abstract, it requires a thing to be extended. It needs a subject, as it's something concerning that subject. It's not something abstract. I mean, Leibniz is a critic. It's critical. It's going what it. I mean, the polemical objective of Leibniz is the res extensa and the geometry, the Cartesian geometry, in which there is this distinction between the res cogitans and the res extensa. In the organism of Leibniz, there is not this distinction altogether. As the extension is just something abstract, it requires a thing to be extended. It needs a subject, as it is something concerning this subject, like a duration. It also presupposes something in this subject. It presupposes a quality, an attribute, a nature that extends itself, stretches itself, that continues in this subject. The extension is the diffusion of such a quality or nature. Whereas Descartes saw the spatial extension as an inert substance and used real numbers as coordinates of the point in a given space, Leibniz breathes continuity into geometrical points which become active subjects. Hence, in a point's view, the extension of space coincides with its visual field. All this implies a suggestive reversal of the epistemological issues that no longer lies in making objective the representation of a shadowless world on a fixed mathematical cage, but rather in looking for a consistent view along the path of shadows. So the artificial perspective marks the beginning of a passage in the Renaissance from an ontological conception of the world to its symbolic representation. This passage, which appears today at the origin of a science of possibility and relations in contrast to a science of beings and substances, calls attention on the problem of expressive forms. The point at issue is not whether art, a free creative activity, was able to become a science following precise mathematical laws, but rather how theory of art and theory of science managed to shake the principle of the past tradition. In the 15th and 16th centuries, artists were the first to revise the relationship between subject and object, self and nature, freedom and necessity. So polymaths like Leon Battista Alberti, Piero della Francesca or Leonardo played an indisputable crucial part in this transition. Perhaps the complexity of the passage finds a more eloquent expression in the work of a polymath like Gerolamo Cardano. According to Maurice Klein, he bridges the gap between the Middle Ages and modern times. Philosopher, mathematicians, astrologer, magician, gambler, and professor emeritus of medicine at the University of Bologna, Cardano embodies the model of a 16th century intellectual struggling between the official tradition and the official traditional knowledge and the emerging or re-emerging humanistic culture. If the subtilitate, one of his major philosophical work, De Subtilitate, overshadows the hard edge clarity of the Quattrocento paintings. Subtilitas for Cardano means something ambiguous, objective and subject at the same time. Subtle is the fabric of a universe composed of imperceptible, unstable elements, continuously transforming. Subtle is an intelligence able to reach the deepest relationship, to discern the smallest part, and therefore to grasp the subtilitas of nature itself. Thus, it's the subtilitas that, mediating between nature and thought, object and subject, allows human freedom to interact with natural necessity. By this notion of subtilitas, Cardano is led to conclude that reality is not what the eye sees, but the intelligence decomposes and discriminates. The painter's eye can see a subtilitas beyond the form of Plato's solid, and this is masterfully rendered by Leonardo's illustration of the Divina Proporzione by Luca Pacioli. Of course, you can see that also the illustration that we have seen before were by Leonardo. And the point is that now Leonardo is also illustrating the polyedra that are not the natural solid or the natural polyedra that, of Plato, but polyhedra that are constructed according to rule of symmetry, but are not what were called, what's recognized as natural solids. So the pentahedral, sorry, I've lost the, here. The pentahedral can see a subtilitas beyond the form of Plato solid is masterfully rendered by Leonardo's illustration of the Divina Proporzione by Luca Pacioli. To let painting support a mathematical vision, Leonardo depicted a series of polyhedra which Pacioli called dependenti beside the 5 Platonic solids. The point to stress is that Leonardo set the polyhedra in a perspectival configuration which emphasizes their spatiality and visualizes them not as abstract entities, but rather as objects of experience. The plastic impression rendered through the shadows and the tension of ribbon holding an object, not a pure geometric object, endowed with weights, reflects the wish to make as much objective the Platonic solids as the innumerable imaginary solid, to make the one equal, figuratively speaking, to the others, so that all of them can be treated as if they were natural. In this way, the eye of nature, according to Leonardo, triumphs over nature in that the constituent parts of the nature are finite, but the words in which the eye commands of the ants are infinite, as is demonstrated by the painter in his rendering of numberless forms. It could be reasonably be conjectured that just from Leonardo's illustration, Cardano drew the conclusion that the geometry of vision fails to represent phenomena seen in 3 dimensions because it describes only the front surface of a solid. What allows one to distinguish a square from a cube is not a flat image to be rendered by means of angle and lines of plane geometry, but this is Cardano, that is a judgment deduced from past experience and adapted to the actual visual perception. But our judgment is also triggered by shadows, which is as crucial as light in demonstrating a 3rd dimension which does not impress the eye and cannot be captured on a plane. In fact, we judge real both what we actually see and what we don't see, but conjecture hidden somewhere in the shadow. For Cardano, 4 elements are needed to represent 3-dimensionality. The shape of the object, inferred from visual line, the shadow, the color, and the relationship between the observer's point of view and the object to be represented. Only the first can be expressed in geometrical terms. In contrast with this diminution of geometry, which is unable to benefit from color and shadows, painting adds a dimension even with respect to visual perception. By relating things to a subject judgment, painting is able to discern and to show, although just by conjectures, what eyes cannot see. Painting does not reproduce the object, but imitates the affection of the object, according to Cardano. In providing a representation of a human body, for instance, paintings represent not only shapes, colors, and the proportion of the body, but also conjectures about disposition of the mind. For making visible what is lighted as well as what is shadowed, and for giving form to a judgment, painting is estimated by Cardano as the subtle art, subtilissima omnium. It's adding colors and shadows to the rules of geometric optics that paintings is able to set things out of the imagination. As Leonardo writes, I think that, yes, this was there, such a proportion is between the imagination and the effect as between the shadows and the shadowed body. And the same proportion is between poetry and painting, since poetry set its sting in the imagination of letters, and painting set them out of the eye, from which it received the similitudes as if they were natural. Similar to Leonardo's, Cardano's view of painting conjugates the objective subtilities of the natural world with the subjective subtilities of an intellect able to discern it. If mathematician may be an artist, painter can be also can be not just an artist, but also a philosopher, an architect, an anatomist, a visionary. Indeed, Cardano recognized in Leonardo this exceptional painter. Painting, but is not only able to set things out of imagination, but also to penetrate into the subtle intelligence of nature itself. Sfumato, and here we can contrast the Leonardo sfumato with the brilliant colors that we have seen in the perspective synthesis of form and colors of Piero della Francesca. Sfumato, or chiaroscuro, is the characteristic pictorial means used by Leonardo to render the fabric of nature. More than a way of seeing forms and relating them to one another, the sfumato is also the carrier of an attitude towards content. Conquered by the beauty of form and anticipating somehow the Leibniz vision, Leonardo claimed the primacy of geometry over arithmetic, of continuous over discontinuous quantities, which stems from the incommensurable relations. His vision of painting as a science, however, did not prevent him from losing, actually encouraged him to lose the rules of perspective. He relays painting from the fixed point view and let nature penetrate into the pictorial space. His involvement with nature, visual magic, we can say with nature's subtilities, radiates, for instance, from, we also have seen this beautiful painting already of the Virgin and Child with Saint Anne. This painting is described by Sidney Friedberg with a very rare sensibility. Friedberg said, landscape space has no independent rational, not measurable distance, and no perspectival shape. Not only its forms, but the content that emanates from it are ancillary to the figure group. But while the landscape is accessory to the figures, it also the matrix out of is also as a matrix out of which they grow. And this. Yes, I remember that there was this quotation from. What is interesting in this quotation from Friedberg is the way in which he said that how the group of figures came out from the landscape, and so what I was trying to show is what's happened if we take away the figures and what remains. What remains? Can we have an idea that what Friedberg is saying, that the mind of the painter must transmute itself into the very mind of nature and be the interpret between it and art? Well, I want to just make some how can I say, consideration about what emerged somehow from Leonardo paintings. If there is some kind of affinities between Leonardo paintings and some kind of Oriental painting. If somehow Leonardo painting can be reminiscent of some painting that come from China or from Japan. And I mean, you can, of course, consider this from your point of view, and we can compare our views. Well, Leonardo's paintings has not documented relation, neither historical nor theoretical, to the traditional Chinese or Japanese painting. And yet, we cannot help notice some subtle similarities, which would be worth exploring further. The two forms of painting appears not to connected by a cause and effect relationship, but rather resonant with one another. We could say paired like echo and sounds like shadow and light. As a kind of experiment, I want to show you to let Leonardo guide us towards East. When I said us, of course now I'm taking your point of view, but you have to consider that my point of view is different in the sense that when in the West we considering the Oriental painting, actually Leonardo perhaps is the painter that goes closer to that kind of this kind of paintings, for instance. Here we have an example that is taken from Shimbun Tensho, the landscape of Four Seasons. And the other example is this. This is a view of the Fujisan. And this is a view of the Fuji from the west. The fact that it's from the west and so it's looking east is given by the fact that there is this Seiken Ji, and so is the Fuji view by this part. And as for the rationale underlying Chinese painting, may be appropriate to consider the essential lesson of Shitao that focus on the passage from the informal to form, the simplest one, he says. Just a stroke is already complete as it contains all the possible form. This formation of things, of the emergence of visible form from the invisible background, it shows the passage from the original is not there, the without form, of the not differentiated background, the great simplicity, to the is there, which constructs the diversity of forms in continuous motion. In a universe dwelt neither by God, not by a demiurge, is the first and unique stroke of brush that is in charge of performing all those fictions. Here, the vanishing point of perspective drawing leaves the floor to a very principle of the artistic construction, a creation from nothing. As to the reception of the Western perspective in the East, and in particular in the ukiyo-e painting, here we have, there are references and also there is visual evidence. Well, we know that a painter like Hokusai did not praise perspective. Most probably he saw it as a useless mathematical cage. By the way, I was saying to Okada-sensei that I've just noticed that today is the anniversary of the 31st of October is the anniversary of Hokusai's birth, of course. So I think that this is, I like the fact that this lecture is on the day of the anniversary of Hokusai. And, well, I was saying that Hokusai didn't like perspective. Nevertheless, he undoubtedly grasped the symbolic significance of perspective very well. One among many examples from Hokusai paintings is this view from the Fuji. Now this is from the east because this is from Edo, and it's also a way in which the east is looking to the west, because it's the way in which Japanese painter use the artificial perspective. And what is interesting what I find interesting in this representation, that is the representation of Nihonbashi, that is the center now, is the center of Tokyo. And I was listening a lecture of Timon Screech and on the globalization, a global interpretation of Nihonbashi. And I found this really inspiring because he was saying that, here what Timon Screech said. Edo's area initially is rather outlying place. In fact, that area called Musashi was not only offline, but was the very daimeshi, the byword for absence. In the poetical tradition, Musashi stands for the absence of everything. It's the place where all you can see when you go there is tall grass, nothing. And that space of nothing becomes the center of the shogunal regime. Well, mastering with remarkable ability the rules of linear perspective, Hokusai locates the center of the shogunal regime precisely on the vanishing point. The shogunal power, or perhaps we should say the temporal political power, grows out of nothing. Now, if we compare that space of nothing with which now we know will become the center of the modern city of Tokyo, with the center of the ideal city of the Western Renaissance worldview, we can also gain a perspectival view on the way in which light and shadows coalesce into the symbolic form of our culture. As for a moral to be possibly drawn from all this, well, we might look back at the Docta Ignoranza by Nicola Cusano. There we can find already crystal clear how the symbols overshadow the logic of finite. A symbol can point to the absolute because it's not simply an image, wrote Cusano in the Docta Ignoranza, which depends on quantitative relation. To see how a line equals a triangle, the puzzle of Trinity again, the intellect ought to transcend perception because line and triangle are not related by proportion. Seeing how a polygon relates to a circle requires a similar departure from perception. The intellect is to the truth as the polygon is to the circle. For the truth is absolute necessity, which can never be more nor less than it is, whereas our intellect is only possibility. This shows that what is necessary for not quantitative figures like a circle, it's impossible for the quantitative one like a polygon. Knowledge, for Cusanos, requires both separation and participation, and light can only be seen in relation to shadow. Thank you.